Hello friends, welcome back to Pharma-info with Shubhashish. Now today's topic is synthesis of prochlorperazine, right? So prochlorperazine, it belongs to the chemical category of phenothiazine antipsychotic, right? So it is a member of phenothiazine antipsychotic. So apart from its application in psychosis, the principal use of prochlorperazine is in the treatment of nausea, then vomiting, even in vertigo. You can say that though it is a member of phenothiazine antipsychotic, but the primary use or primary application is in the treatment of nausea, vomiting and vertigo. We have seen because in my previous videos, one of the videos was of chlorpromazine. There we found that apart from its antipsychotic effect, it do possess anti-emetic effect. Okay, that is why nausea and vomiting, right, it can work well on this particular clinical condition, and vertigo, this can be given, right? And moreover, if we just try to compare the side effects, extrapyramidal side effects of chlorpromazine and prochlorperazine, here it is found to be more prominent. That means here the D2 block, the D2 dopaminergic 2 receptor blockade is found to be more pronounced than that of chlorpromazine. That is, as a result of this, though we are getting this kind of benefit, but still the extrapyramidal side effect, that means Parkinson-like symptoms, okay, definitely will arise, right? Okay, out of long exposure of this particular drug, right? Chalo. So now without wasting much time in the pharmacological aspect, let us just move to the the chemistry of this prochlorperazine, right? The chemistry, I mean to say the structure, the IPC name, and the making of prochlorperazine, right? Chalo. So now prochlorperazine, okay, parazine, zyne means parazine. That means if we just try to just articulate this one. So if we just write piperazine, just IP, Indian pharmacopoeia, it has been kept. So piperazine. So piperazine is found to be the ring system that should be accompanied with the phenothiazine, right? So that means it is expected that probably there is a modification in the side chain, the one which we observe in case of chlorpromazine, that should not be there with prochlorperazine, because I have already uploaded a particular video on this SAR of phenothiazines. There you while going through that particular thing, you can get an in detail explanation was there, right? And in detail explanation was there. Okay, so on the basis of the pattern of side chain, okay, which are kept at N10 of phenothiazine, okay, they can be categorized into three different classes, right? Three different classes, and one of the classes found to be piperazinyl alkyl side chain. So piperazinyl alkyl side chain, and the member belongs to that particular family or subfamily is found to be prochlorperazine. So how the structure will be? So we know that first. Let us just move on to let us just build the structure of the template. The template is found to be something like this. We have to insert a chloro. The explanation was done in the last video, as well as the SAR of phenothiazine as an antipsychotic. Then we have to put something here. Here it is CH2, then again CH2, and finally we have to put a piperazine, and to that piperazine the other end should be inserted with a methyl, right? So this is a prochlorperazine. Often you can find while just going through the formulation, you can find that prochlorperazine is given in the form of a salt of prochlorperazine maleate. That means it's a salt of malic acid, right? Chalo. So now this is found to be the structure of prochlorperazine. Now let's see that how the IPC name can be developed, right? How the IPC name can be developed, right? Chalo. So how the IPC name can be developed, and let me tell you one thing. See, this is whether it is the alkyl chain is made up of 2 carbon or 3 carbon or some other thing. How do you come to know, right? See, the name itself suggests pro for propyl, clo for chloro. There is no other electronegative atom which may be there at second position, right? Chlor. The name itself suggests prochlor. Then parazine. Parazine means piperazine. The rest, only thing that you need to remember that the other end is having a methyl. This is the only information that you should, by heart, you should remember. The rest will automatically come from the chemical class, at the same time the name. Nothing extra you need to remember here. Everything is has been kept in the name itself, right? Okay, chalo. or we can say the most of the things have been kept in the name itself, right? So let's move on. So how the IUPAC name can be generated here. So there is no amine, so that means we should not give preference to the the side chain. Instead, we should give preference to the all in a row arrangements, to the biggest one, okay, to the biggest fuse system, right? So this is nothing but phenothiazine. So we'll put phenothiazine here. Why? Because at the end of the process, or just while completing the naming and all, you have to put the name of the parent, right? So this is phenothiazine, right? Okay. So phenothiazine is holding what? At its second position we have a chloro. So likewise we should write 2-chloro, followed by this is 2-chloro, and then we have substituent, the major substituent kept at position 10. 1, 2, 3, 4, 5, 6. Sorry. Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? S5 and 10. Right? So what is there at position 10? So position 10 is holding what? A propyl alkyl chain. Right? So this is 1, this is 2, this is 3. The third position is holding what? A piperazine. So it is the first nitrogen that is directly linked to the third carbon of this alkyl chain, and the other end, that is at fourth position of piperazine, we have a methyl. So likewise, so this is 10, and after that we should write here 3. Why? Because the 3 of this carbon is holding what? The 3 of this carbon is holding 4-methyl, then piperazine, zine means, as it is acting as a substituent, you are not supposed to write zine. That means E should be left out, right? Zin, you should stop, right? And then 1-yl, then close the first bracket. Then 3 itself is the number of this alkyl chain, that means propyl. So we should close the bracket, and then what is left in the process? That means phenothiazine. So we are done with this. We are done with the IUPAC naming and all, right? So this is about the IUPAC naming. Now let's move on to the making, right? So making. So without wasting much time in rubbing off and all, right? Let us just keep the name itself, keep the major portion as such. So what can be done here? What can be done here? Let's see the location which can be broken down, or where the splitting operation can be done. So this is the area, right? This is the area, right? At least we can separate these two halves, right? Oh, two halves from this region, right? Chalo. So while splitting or while breaking this one, so this is found to be one of the fragment. In a straight way, blindly you can put hydrogen. So just try to make it 2-chlor 10H phenothiazine, right? So this is found to be one of the starting materials. Now what is the other one? The other one is having an alkyl. Let us skip each and everything as such. Only thing is that here we have to put one hydroxyl. Here we can put one hydroxyl, right? Okay. So here we can put one hydroxyl, but it's very difficult, okay? If we just try to react this hydroxyl with this hydrogen, it's very difficult to remove the H2O. In this process, right? In this process, because after all, the merging has to be taken place in presence of sodamide, NaNH2. If this has to be taken place in presence of NaNH2, so that means the hydroxyl should not be there. Instead, as usual, the electronegative atom, that means X. So here X is nothing but a chloro. Because chloro is electronegative, electron withdrawing. Hydroxyl is not electron withdrawing, it's an activating group. It's a nucleophile, right? Chalo. It's a nucleophile. Now, so this is the chloro that has to be react with, this phenothiazine. So plus this, in presence of sodamide, we have given the explanation why you are not supposed to make it CH2OH. Instead, this has to be made CH2Cl, right? And this has to react with this phenothiazine, and in presence of sodamide. So what will happen? HCl will go off and the merging will take place like this, and finally we can get what? Prochlorperazine. Now treat these things with malic acid. There is a formation of what? Malic, salt of prochlorperazine, the salt of the salt of malic acid. That means prochlorperazine maleate will form, right? That is found to be the one which is incorporated in a formulation, right? As such, this cannot be incorporated like prochlorperazine maleate, like chlorpromazine hydrochloride. Most of the drugs, they are given in the form of a salt, right? So with that, I am done with the making of prochlorperazine. Hope you have understood this one, and thank you for your kind patience. Thank you, and stay tuned and wait for the next video to come. Thank you.